Students, we know that Rutherford has drawbacks in his nuclear model of atom. He told electrons revolve around the nucleus in circular path and it is continuously accelerating towards the center of the nucleus. But according to classical dynamics, what is going on is an accelerated particle should continuously lose their energy and thus radius of the path will decrease and finally fall into the nucleus by spiral path. So he failed to explain the stability of the atom and also he failed to explain the emission of line spectra by the hydrogen atom. Later, Bohr, using the classical and quantum concept in order to give a model for hydrogen atom. He had three postulates. One among that is an electron in the atom could revolve around a certain stable orbit. There are many orbits. What Bohr postulates is electron in an atom could revolve in certain stable orbit without the emission of radiant energy. It means electron can revolve around the nucleus in definite stable orbit, either in this, or still more that there. We have some shells, KLMN shells. You will be seeing in your future classes. So what Bohr says is that electron can revolve around the nucleus in a definite stable state and these states has definite total energy. These states are known as stationary states of atom. Stationary means being in stationary means nothing but it is at rest. Okay, so it was his first postulate. It means that electrons revolve in a definite stable state and this stable state has definite total energy and these states are known as stationary states of the atom, right? In the second postulate, what he told is electron revolve around the nucleus only in certain discrete non-radiating, as he told, it is a stationary orbit, right? Stationary state in a stable orbit. So electron revolve around the nucleus only in a certain discrete non-radiating or stationary orbit for which angular momentum is an integral multiple of h by 2 pi. That is L is equal to nh by 2 pi. H is nothing but Planck's constant. Why it is Planck's constant? Because Planck is the one who discovered the value for h. 6.63 into 10 raised to minus 34 joule second. This implies that the angular momentum of the orbiting electron is quantized, that is L is equal to nh by 2 pi. L is also mvr is equal to nh by 2 pi. mvr, angular momentum, you have seen in your lower classes about angular momentum, right? So angular momentum is given by m into v into r is equal to nh by 2 pi. Here n is the positive integer, m is the mass of the electron, velocity of the electron, radius of the orbit. Keep in mind, mass of the electron, velocity of the electron, radius of the orbit, and n is the positive integer. Now in his third postulate, when an electron makes transition from one of its specified non-radiating orbit to another of lower energy, a photon is emitted having energy equal to the energy difference between initial and final state. That is, students, you have seen about photoelectric effect in your lower classes. The same goes here. When an electron makes a transition from his higher energy level to lower energy level, it emits photon, right? This photon emitted will be having equal energy difference. This energy of this photon is equal to the energy difference of these two, initial as well as final state. If let us take EI has the energy in the initial state EF is the energy in the final state of the electron. Then frequency mu, frequency is denoted in this way. Frequency mu of radiation emitted is given by h mu is equal to EI minus EF, energy of the electron in the initial state, energy of the electron in the final state. The radii of Bohr's stationary orbit can be estimated using Bohr's second postulate. So Bohr's second postulate is here. So let us take as Ln is equal to mVnRn, which implies mVnRn is equal to nh by 2 pi, right? So let us take this part. Only this part is enough. So we have this from Bohr's second postulate. Here n is a positive integer. Rn, why it is taken as Rn? Because it is the radius of the nth orbit. Vn is the speed of the moving electron in the nth orbit. So the allowed values for n is nothing but 1, 2, 3 and all, and this n is known as principal quantum number. Students, once again I'll repeat the third postulate. In third postulate, it is nothing but when an electron makes transition from its specified non-radiating orbit to lower energy, a photon is emitted having energy. This photon will have the energy equal to the energy difference between the initial and final state. So if EI is the energy of the electron in the initial state, EF is the energy of the electron in the final state, then frequency mu of the radiation emitted is given by h mu is equal to EI minus EF, initial and final state. So from the second postulate of Bohr, we have Ln is equal to mVnRn is equal to nh by 2 pi. So let us take this part. We have this. Here Vn is the speed of the moving electron in the nth orbit. Rn is the radius of the nth possible orbit. N is an integer, positive integer. N can have the values of 1, 2, 3 and goes on. This n is known as the principal quantum number. Now, with the Coulomb's force of attraction, Coulomb's force of attraction, where it acts between nucleus and electron revolving in an orbit of radius Rn, that is given by E square 4 pi epsilon naught Rn square. We have seen in. So this force provides the necessary centripetal force of the electrons to circulate. So centripetal force is given by mVn square by Rn and E square 4 pi epsilon naught Rn square. I think you remember the centripetal force. Okay, this goes in this way. Centripetal force is given by mv square by r. So we take n because it is in the nth orbit. So mvn square can be written as, so we cancel here. What we will remain with is E square 4 pi epsilon naught r n. Let us take this equation as 1, or let us take this as 1 and this as 2 for our convenience. Please keep in mind the numbering is for our convenience, not for any other purpose. Now according to Bohr's third postulate, what we know is L is equal to m is constant, mVnRn is equal to nh by 2 pi, right? Now Vn is equal to nh 2 pi mRn. Now let me take this equation as 3. Now with this, let us get the expression for radius of nth orbit of hydrogen atom. Expression for radius, that is Rn for nth orbit. Now if we substitute equation 3 in equation, this is equation 3 and this is equation 4. So for the expression for radius Rn, let us substitute equation 3 in equation 2, that is substituting Vn in this equation. So we have mVn square is equal to E square 4 pi epsilon naught Rn, right? We have to substitute the value of Vn in this equation. So what happens? M into n square h square 4 pi square m square Rn square, right, is equal to E square 4 pi epsilon naught Rn. We have m here, pi square and here pi, 4 is also cancelled. So what we will remain with? N square h square epsilon naught E square Rn, right? If you take this here, now what we really require is Rn, because we are going to get the expression for radius. So Rn is equal to n square h square epsilon naught divided by, we have pi here, pi and also m, pi m E square, right? Pi m and E square Rn. Okay, so we'll get the expression thus. If you want, once again I can explain you from the beginning. See, we have Coulomb's force of attraction. So centripetal force is given, required by this electron is given by Coulomb's force of attraction between the nucleus and the electron. Therefore we know centripetal force is given by mvn square by Rn, mv square by R, but here we are going to study about the nth orbit of the hydrogen atom, so we have taken Vn Rn is equal to Coulomb's force of attraction, and we arrive at this expression. Let us take that expression has 2. From the third postulate we have mvn Rn is equal to nh2 pi, and we'll arrive at the expression for Vn. Now in order to get the expression for radius, we will substitute Vn in equation 2. So after substituting here, we'll arrive at the expression for radius of nth orbit of the hydrogen atom, that is Rn is equal to n square h square epsilon naught divided by pi m E square. Here in this expression, h square epsilon naught by pi m E square, this remains constant throughout. Okay, only n varies here. For example, if you take n is equal to 1, then R1 is equal to h square epsilon naught pi m E square. This is also denoted as A naught. This is nothing but Bohr's radius for hydrogen atom. If you take n is equal to 1, then we will have arrive at this expression. This is nothing but A naught. A naught is nothing but Bohr's radius. So Bohr's radius is nothing but, it is the innermost orbit, radius of innermost orbit of an electron in hydrogen atom. Innermost is n1. N is equal to 1 is the innermost radius. Innermost radius of the, it is radius of innermost orbit. Bohr's orbit is nothing but radius of innermost orbit of an electron, that is orbit of electron. So if you, since these are all constant, we know the values of Planck's constant, epsilon naught, pi m and E square. So if we substitute, what we will get? So E naught is equal to h square epsilon naught pi m E square, right? So if we substitute the values for h square, 6.63 into 10 raised to minus 34 joule second, and the value of epsilon naught is 8.85 into 10 raised to minus 22 pi 3.14 9.1 into 10 raised to minus 31 kg into 1.6 into 10 raised to minus 19 coulomb. So we arrive the value has A naught 0.53 angstrom. So after substituting the values of the constants, we will get A naught has 0.53 angstrom. So with equation 4, that is with this equation, what we get the result is that Rn, that is the radius of nth orbit of the hydrogen atom, is directly proportional to n square, the principal quantum number. Square of the principal quantum number. Radius of an orbit is directly proportional to the square of the principal quantum number. Now let us move on to get the expression for speed of electron, that is Vn in the nth orbit of hydrogen atom. So what we have, Rn is n square h square epsilon naught by pi me square. So we have arrived this expression. So we have this expression. Now substituting this Rn in Vn, nh by 2 pi m Rn. So we have the value of Vn over here, that is equation 3. Substituting Rn, the arrived expression just now, substituting for that in equation 3, what happens? Let us see. You have to substitute Rn in Vn. Rn in Vn, right? So Vn is equal to nh 2 pi em n square h square epsilon naught by pi m e square. Right, students? I think everyone knows how to deal with this. Vn is equal to nh pi m e square 2 pi m n square h square epsilon naught, right? Now with the deletions, we get Vn is equal to e square by 2nh epsilon naught. Here e square by 2h epsilon naught remains constant throughout. So Vn is directly proportional to, inversely proportional to n. This implies speed of moving electron Vn is inversely proportional to the principal quantum number. For hydrogen atom, that is n is equal to 1, that is the innermost orbit, we have V is equal to 2.2 into 10 raised to 6 meter per second. For hydrogen atom, the innermost orbit of hydrogen atom, V is 2.2 into 10 raised to 6 meter per second. We arrived this value from applying the constants, applying the values of the constants. So once again I'll explain. In examination point, you have to write from the beginning till here, and you will be asked to find the expression for radius or velocity or energy. So till here you have to write it, it's mandatory. Then you have to, using this, you have to arrive at the explain, whichever they ask. Either they may ask radius, either they ask velocity. So we have Rn value from the previous, that is radius of nth orbit of the hydrogen atom. So substituting Rn in Vn, that is equation 3, we arrive at the expression Vn is equal to E square by 2nh epsilon naught. Here E square 2h epsilon naught is a constant. Variation is only with the n. Therefore, speed of moving electron in the nth orbit of hydrogen atom is inversely proportional to the principal quantum number. For the innermost orbit of hydrogen, that is n is equal to 1, we have the value for speed of velocity has 2.2 into 10 raised to 6 meter per second. Now let us see the expression for energy. We have already seen this in the case of Rutherford. Now in case both are same, okay, don't need to worry. The total energy of electron of nth orbit is nothing but it is a sum of kinetic energy and the potential energy in the nth orbit, right? So kinetic energy is given by half mvn square. And we know what mvn square is from equation 2 in the previous. So here, this was the expression we started with. So we have arrived the expression for mvn square. So here we can write the value of mvn square, that is E square 4 pi epsilon naught Rn, right? Therefore kinetic energy can be written as, let us take this off here, half mvn square means E square by 4 pi epsilon naught Rn, right? This is kinetic energy, expression for kinetic energy. Now what about the potential energy of nth orbit? It is nothing but electrostatic force. Electrostatic potential is given by E is equal to E by 4 pi epsilon naught Rn into charge on the electron, that is in this case it is minus E. In the case of Rutherford it was 2E, right? And it here was Ze. But in case of Bohr, it is E by 4 pi epsilon naught Rn into charge on the electron, that is minus E. We arrive potential energy as minus E square by 4 pi epsilon naught Rn. Now total energy En will be E square 8 pi epsilon naught Rn, that is the kinetic energy, minus E square 4 pi epsilon naught Rn. This is the potential energy. So finally we arrive at the expression as E square 8 pi epsilon naught Rn. Right, students? But we know Rn as n square h square epsilon naught pi m e square, right? Now substituting this value in equation En, we get En is equal to minus E square 8 pi epsilon naught. So value of Rn is n square h square by epsilon naught pi m e square. So what happens here is En is equal to, this goes up, and deleting the things we get minus m e power 4 divided by 8 n square h square epsilon naught square, right? Now in this condition, if you give the values of all the constants, we will arrive as En is equal to minus 13.6 by n square electron volt. The only variable here is the n. So if you give the values of the constants here and calculate, you will get minus 13.6 divided by n square electron volt. Here negative sign indicates that electrons are bound to the nucleus. So this is the expression for energy of the nth orbit of the hydrogen atom. So students, I think you understood very well. So total energy is given by kinetic energy and the potential energy, right? So potential energy we know half mv square, but we have arrived the expression for mvn square in our previous derivation. So Vn square is given by E square 4 pi epsilon naught Rn. So kinetic energy is given by E square 8 pi epsilon naught Rn, right? Now about potential energy. In case of Rutherford it was 2E, but in case of this we have minus E here. So potential energy is given by minus E square 4 pi epsilon naught Rn. So total energy is this much. But we know the value of Rn. Substituting for the value of Rn, we arrive at the expression m minus me power 4 by 8 n square h square epsilon naught square. When we add the values of constants, we will get En is equal to minus 13.6 by n square electron volt. Here negative sign indicates that electrons are bound to the nucleus. Now let us arrive at the expression for frequency of electron in the nth orbit. So expression for frequency, that is mu n in the nth orbit. Now velocity, we know velocity is given by Vn Rn omega. I think everyone knows this. Omega is nothing but 2 pi mu. So Vn can be written as Rn 2 pi mu n. Frequency omega s 2 pi mu n, that is omega n. Okay. So we have mu n is equal to Vn 2 pi Rn. But we know Vn is E square 2 nh epsilon naught and Rn is n square h square epsilon naught by pi m e square, right? We have arrived the expression for Vn and Rn in our previous expressions or the derivation. So substituting these two values in mu n, we get mu n is equal to E square 2 nh epsilon naught 2 pi here, and substituting for Rn we get pi m e square by n square h square epsilon naught. Because it is in the denominator, I wrote it in this way. So mu n can be written as m e power 4 divided by 2 n cube h cube epsilon naught square. Once again here m e power 4 2 h cube and epsilon naught square is a constant. Therefore frequency is inversely proportional to the cube of the principal quantum number. So this itself is about this derivation. So in this session we have seen the expression for radius, expression for velocity or the speed of the moving electron, and expression for total energy of the electron and the frequency of the electron, all in the nth orbit of hydrogen atom.